Okay, I'm going to do a lot of examples, I think 4 total, of proving that arguments are valid. And my hope is by the end of all of these, you feel very, very comfortable with the different rules of inference and using them in proofs. So the first step always is going to be to label things as P, Q, R, S, however many we need. And the way you can do that is just kind of underline when you see a new noun or a new verb. So I see that we can say P is it rains. Q can be the ground will be wet. And then PQR, R can be the game will be canceled. Okay, the next thing I want to do is match these premises with their symbols. So we can just put symbolic representations of those 3 premises and the conclusion. So the first premise, if it rains, then the ground will be wet. That's P implies Q. The second premise, if the ground is wet, that would be Q, then the game will be canceled. Q implies R. And the last one, it says it rains. So that's P. And the conclusion, we put these 3 dots to mean conclusion. Therefore, we can conclude the game will be canceled, which is R. So in order to prove this, you want to create 2 columns. You'll do statements and then justifications or reasons. And usually the best place to start is just by using the first premise. The first premise we found was P implies Q. And anytime you just restate a premise, you say hypothesis, or you can say premise, or you can say given, meaning we were given these things, so we're allowed to use them. Now, I don't think I can do anything from here, so let me pull up another one of the hypotheses or premises, and I'll pull up the second one. Q implies R. So again, the reason I can put that in my proof is that it's a hypothesis. It was given. But now I look at the rules of inference, and when you have P implies Q and then Q implies R, you can make the logical conclusion that P implies R. It's like we skipped, it's like train cars. P goes to Q, Q goes to R, so we can directly start at P and land on R. And that rule of inference is called the hypothetical syllogism. Hypothetical syllogism. And it's always a good idea also to write which steps you are using. So that was steps 1 and 2. All right, well now I have that, and I'm not sure what else to do. So let me pull up the third premise, and I'll say P. P happened right there, so I'll just say that's another hypothesis, that's another premise. And so now look at steps 3 and 4. If you have an implication P implies R, and then P did in fact happen, then I can conclude that R must happen. And this rule of inference is called modus ponens. That's where if you have an implication P implies something, and the first thing happens, then that means that second thing must happen. So it's modus ponens, and I'm using rules, steps number 3 and 4. So as soon as you get down to the conclusion, then you have proven it. You've proven the argument is valid. Okay, let's try another one. Again, you just start off by underlining the important words. I only see 3 important words, so we will make 3 propositions, P and Q and R. P is I study. Q is I pass. R is I went to the party, I go to the party. It doesn't matter if you will go or you went in the past. That doesn't matter. I go to the party. So if we were going to rewrite the premises 1, 2, and 3 with a conclusion, which is this therefore statement, 1 says, if I study, then I will pass. That's saying P implies Q. 2 is I did not pass, so that's not Q. And R is I'm sorry, R. The third one is I either studied, so that would be P, or I went to the party, which is R, and then the conclusion is I went to the party, R. So again, when you're trying to prove a valid argument, you need to make two columns. You need to make statements and justifications or reasons. And when you don't know where to start, it's always best just to start with the very first premise. We have P implies Q, and the reason I can write it is because it's a hypothesis or a premise that is given. All right, I don't know what to do from here, so let's go ahead and just write the second hypothesis, not Q. It's another hypothesis. And now I actually see that this format matches one of my rules of inference. So we have a rule of inference that says if you have an implication, P implies Q, and then the second thing did not happen, then we can conclude that the first thing did not happen. And this is called modus tollens. Modus tollens, and I'm using steps 1 and 2 in my reasoning. Okay, well, I'm kind of stuck there, so when I get stuck, I'll look back down to my premises and pick the one I didn't use. So I haven't yet used this one, P or R, so I'm going to call this a hypothesis. I just pulled it up from the given premises. But now if I look at steps 3 and 4, there is a rule that matches this. And it says if you have an or statement, P or R, but the first thing did not happen, then we can conclude that the second thing must have happened. And this is called the disjunctive syllogism. Now you're going to be given the formula sheet that has all those rules, so you should just be comfortable with them, but you don't have to have the names exactly memorized. So that's the disjunctive syllogism based on steps 3 and 4, but this is what we were trying to prove, so we did indeed prove it. Okay, here's a third one. Again, you just want to start off by underlining all the different words that you see. I see 4 different words. So I think we'll need a P, a Q, an R, and an S. The P is you go to the store. Q is you buy eggs. R would be bake a cake. And S is buying milk. Okay, so again, we'll write these 3 premises and the conclusion. These 3 dots mean therefore. So the first premise says, I will go to the store and buy eggs. So that's P and Q. Second thing is, if I buy eggs, so if Q, then I will bake a cake. I will bake a cake is R. If I go to the store, I will also buy milk. So if I go to the store, so if P, then I will buy milk, which is S. Sorry, I don't like how that looks. Okay, the conclusion being, I will bake a cake and buy milk. So baking a cake is R, and buying milk is S. That's what we'll be trying to prove. So again, we're going to make 2 columns. We're going to have statements and then reasons. Okay, it's always a good idea to just start with the first premise. So we have P and Q, and that's a hypothesis. It's a given premise, so we're allowed to use it. And actually, just with this one statement alone, I can draw some conclusions. I can decide that P happened, since both P and Q happened. That is going to be a rule called simplification. Simplification says if you have something and something else, then it's okay just to list the first thing or just to list the second thing. So I'm going to go ahead and list both of those. Again, they're both by the reason of simplification. So not only do I know I go to the store and I buy eggs, I can just say that standing alone. I go to the store, that's its own statement, and then I buy eggs, that's its own statement. So why does that help us? Well, let's go to the next premise. The next premise says, if Q, then R. Okay, that's a hypothesis. I'm allowed to rewrite it because it's just one of the given premises. But now look at these two steps. Look at steps 3 and 4. So if you have a proposition, Q implies R, and then the first part of it did happen, Q did happen, according to step 3, then we can conclude that R must have happened, and that is, the reason is called modus ponens, and we will base this on steps 3 and 4. Okay, now what should we do? Well, when we're stuck, let's go down and we've already used this hypothesis, we've already used this hypothesis, now let's use this one. 6. P implies S. This is also a hypothesis. Now usually when you have implications, you either want the first thing or you want the negation of the second thing. Look, I have the first thing. Okay, so based on steps 2 and step 6, I know I'm going to use steps 2 and step 6. I have an implication, P implies S, but then P did happen, so I can conclude that S must have happened, and again, this is modus ponens. I have an implication, P implies S, P did happen in step 2, so I can make the conclusion S. Now we're almost there, but now let's move to step 8. Let's use a nice bright color. Since I have R and I have S, then I'm allowed to join them together and say R and S, and the reason for this is called conjunction. If you have two individual things, you are allowed to combine them together with and that's from steps, let's see, 5 and 7. And now, since through my rules of inference, I was able to conclude the conclusion, then I have proven it is a valid argument. Okay, let's do one last one. We've got database is running, website is accessible, the monitoring system, sending an alert, running network. Okay, it looks like I need 4 things. So P will be database is running. Q will be website is accessible. R will be, now this says the system will not send an alert. I'm just going to say the system does send an alert. System sends alert. It's always better to take the nots out, and we will just call that not R when we're translating. System sends alert, and S we have network is down. Okay, so now we need to translate these 4 premises and a conclusion. Let's see what the premises say. If the database is running, so that's P, then the website is accessible. P implies Q. If the website is accessible, so Q implies the monitoring system will not send an alert, so that's not R. The monitoring system does send an alert, so that's R. And then we have either the database is running or the network is down, so that's P or S. And then we conclude S. All right, so again, we have statements, and we're going to have reasons. And whenever you don't know where to start, it's always a good idea just to start with the first one. P implies Q. This is a hypothesis. And then not sure what to do, so let's take the next one. Q implies not R. This is also a hypothesis, but I see a rule of inference I can use. Whenever you have 2 implications, P implies Q, Q implies R, you can actually skip that middle step and just directly say P implies not R, and this is called the hypothetical syllogism. We did an example with one of these, and we're basing it on steps 1 and 2. Okay, moving on. Let's see what we have. Not sure what to do, so let me go back to the hypotheses. We've used this one and this one. Let's try this one. R. So that's a hypothesis. And I noticed something about these two. When you have P implies not R, and then you have the opposite of that second item, this is actually the use of modus tollens. So you have P implies something, but the opposite of that thing happened. So then we can conclude not P. And this is modus tollen using steps 3 and 4. Okay, let's look at step 6. Not sure what to do, so let me go and find my last hypothesis. P or S, that's another hypothesis. And oh look, because I have not P and I have P or S, then I should be able to conclude when you have an or statement, the first thing or the second thing, but the first thing did not happen, then we must conclude the second thing did happen. And this is called the disjunctive syllogism, based on steps 5 and 6. So again, I did get to this last conclusion, and I used all of these rules of inference to prove it. So hopefully all these examples will help you. Good luck.